Okay, so you know the difference now between a permutation and a combination. Let's put this to practice. In your textbook, you're going to see this permutation formula. You don't really need to know it because you already know the fundamental counting principle. So this year, for this class for algebra, you don't really need to know it, but we're going to use it because we're in enrichment, might as well try it. And it's something that you will see maybe on the algebra keystones or the algebra PSSAs, one of those standardized tests, okay? So I just want to show you how you can use it. You are going to need to know how to simplify expressions with this exclamation point that you see. So an exclamation point is a factorial, and I want you to write that down. All a factorial is it's a shortcut way of writing out an extended multiplication problem. So what this would mean, for example, if I said 4 factorial, is it's going to be that number that you're going to see there times every integer until you get down to 1. So 4 factorial means 4 times 3 times 2 times 1. So make sure you write that down underneath your permutation. You need to know what that is and how to evaluate it. So 4 times 3 is 12, 12 times 2 is 24. So factorial means it's that number multiplied by every integer between that number and 1. So a group of 8 swimmers are racing at a competition. Different prizes are given for first, second, and third place. How many different outcomes can there be? When you think about this, if order matters or doesn't matter, I don't know about you, but I would much rather win first over second and over third, right? Because they're specifying there are different places, the order does matter. So this would be a permutation. The total number that I have is 8. So that's my total. That's going to be in this formula up here, my n value. And how many am I choosing? Well, I want to figure out how many different ways I can choose a first, a second, and a third place. So my 3 is the how many I'm choosing. That's going to be the r value in the formula up there. So n is the total, and r is how many you're choosing. Well, you could do this with the fundamental counting principle, right? Okay, you have first place, second place, and third place. You have 8 options for first place. After one person wins, 7 options for second place, and then you have 6 options for the third place. So it would be 8 times 7 times 6 because you have 8 options for the first, 7 options for the second, and 6 options for the third. So just do this multiplication. Well, 8 times 7 is 56, and 56 times 6, you should be able to do that without a calculator. 6 times 6 is 36, carry the 3. 6 times 5 is 30 plus the 3. So you have 336 ways or orders for this to happen in. Now let me show you this with the formula, and I want you to write this too, because even though you may not be using the formula, you will have to be able to simplify expressions with a factorial. So the formula is going to be n factorial over n minus r factorial. Remember, n is the total and r is how many you're choosing. So since we have 8 total, we would do 8 factorial over 8 minus 3 factorial. Order of operations, you're still starting inside those parentheses, so this is the same as 8 factorial over 5 factorial. So as I was saying, you may not have to come up with this equation, but you will be given problems where you have to simplify that. So you want to make sure you do this with me, make sure you do it on your notes. Well, expand this out. 8 factorial is what? It's 8 times 7 times 6 all the way down until you get to 1. Expand 5 factorial out. Now, before you go and do this multiplication, before you jump to your calculator, think about what you know in fractions. Everything is being multiplied, so this is really just one number divided by another number. And if you have 5 being multiplied in the numerator, but then divided by in the denominator, what would those do to each other? 5 divided by 5 is really just 1, so those cancel out, right? And 4 divided by 4 is just 1, 1, 1, and 1. So all of those canceled. This is an example where you can reduce this before you do the multiplication. So you know that 8 factorial divided by 5 factorial is really just 8 times 7 times 6. because the 5 factorial cancels with the 5 factorial that's hidden in there. So this is just 336. Like I said, you will need to be able to simplify that and show that work to your teacher. One thing I did want to point out, if you have a calculator, whether it's a graphing calculator or a scientific calculator, most of them have somewhere on there a button that says NPR. If you have a grapher, it might be under a menu for math and then probability. But it's probably on there somewhere if you have a probability button. Look around there or under that menu. That would be how you could get the calculator to calculate the permutation for you. Every calculator is different in how you use that, but I just thought I would point it out to you. And again, in the book gives you the combination formula as well. You don't have to memorize this formula, but we're going to practice simplifying from it. That is something you do have to be able to do. So again, N is going to be the total. R is going to be how many you're choosing. The only difference between the permutation formula and the combination formula is they add this R factorial into your denominator. So let's try example 4. Ms. Huff is going to choose 4 students from her advanced algebra class. And you have to look on here because you don't have this, which has 20 students. And I'm going to choose 4 to be leaders for a project. How many different ways can the 4 people be chosen? So this is a combination because I'm just choosing a group of 4 leaders. What is my total that I'm starting with? 20. And how many different, am I choosing? 4, so that's my R. Okay, let's start with this formula here. So we would have 20, choose 4, 20 combination 4. Everywhere you see an N, you're putting in that total. So we have 20 factorial over R factorial times 20 minus 4 factorial. Simplify that subtraction. It's going to look very similar to the permutation formula, except now you have 2 factorials in the bottom. So we have the 20 factorial over 4 factorial times 16 factorial. Now this is not the same as that. Expand it out. You have to be able to simplify this. So I don't really expect you to write out all the integers up to 20. Write it out until you get to that 16 factorial. 20 times 19 times 18 times 17 times 16, and it would be 16, 15, 14, or 16 factorial, right? And then we have 4 factorial being 4 times 3 times 2 times 1 times, because there's multiplication here, that's 16 factorial again. So hit it in here. 16 factorial is really 16, 15, 14, 13, all the way down to 1. Those cancel each other. They're gone. All right. So look at the fraction you have left. Before you jump to your calculator, see if you can simplify anything else. 20 and 4 can be reduced, right? And since it's multiplication, you can cancel them. So divide them both by 4. You have 5 and 1. Is there anything else you can simplify here? 18 can be divisible by 3, and that's going to give you 1 and 6. And now that 6 is divisible by the 2, it's going to give you 1 and 3. So this combination is going to be 5 times 19 times 3 times 17. Now you could use that calculator if you need help with this multiplication. It's going to be 95 times 3 times 17, which is going to come out to 4,845 groups. Crazy that I could make that many groups with only 20 students. On the calculator, this button would be NCR. So if you have it, you can check it out, play around with it, but you do have to be able to show your work and simplify problems like this. Excellent, guys. You're ready to move on.